Here's a new sort of problem. We've got f of x equals x plus 2 sine x, and we're asked to find all the x values at which f has a horizontal tangent. Well, if we have a horizontal tangent, that means that the slope of the tangent is 0. So we're looking for all the places where the derivative is 0. So we're going to find the derivative. We've been doing that. Once we've done that, we're going to set it equal to 0 and solve for x. Let's give it a shot. So f prime of x, we're taking the derivative of x plus 2 sine x. That's just going to be the derivative of x, which is 1, plus 2 copies of the derivative of sine, which is cosine. Okay, so that's f prime. I want that to equal 0. So I'm looking at where does 1 plus 2 cosine of x equal 0. To solve that, I'm going to isolate the trig function. So that means 2 cosine of x equals -1. So cosine of x is -1/2. So basically, this is a review of solving trig equations. All right, I'm going to first of all find x values in one period of cosine. So in the interval from 0 to 2 pi. And I usually include 0 but not 2 pi, simply because once I've done that, I'm going to find all x values. And I'll get that by taking whatever solutions I had here and adding a multiple of 2 pi. So for this problem, 0 isn't going to be a solution because cosine of 0 is 1. It's not -1/2. But if I ever have a situation where 0 is a solution, 2 pi will also be a solution, and I'll get that when I add a multiple of 2 pi to the solutions I get here. Okay, so for the solutions between 0 and 2 pi, I want to just think in terms of quadrants. Actually, I'm going to clear some space, I think. I'm looking for places where cosine is -1/2. So I'm going to have solutions in the 2 quadrants where cosine is negative. I'm going to have one solution in quadrant 2, since cosine is negative there. And I'll have another solution in quadrant 3, because cosine is negative there. For both of those, I'll have a reference angle, which I usually just call alpha. And what I know about that is that cosine of alpha will just give me the absolute value of cosine of x. So that would be the absolute value of -1/2. That's 1/2. So alpha is the acute angle whose cosine is 1/2. Now, some of you may be more unit circle people than I am. If you're a unit circle person, you might have jumped right to the places on the unit circle where cosine is -1/2, and that's fine. I'm more of a triangle person, so I'm now thinking, let's draw my special triangle, the 30, 60, 90, 1, 2, √3, okay, and see which acute angle gives me a cosine of 1/2. Looks like that's 60 degrees. When we're doing calculus, we're always going to be working in radians. Ah, I should make a note of that. We are always working in radians as we do things. The reason for that, when we derived the formulas for sine and cosine, if you remember, when we found the area of the sector of the circle, we said that the angle that corresponded to a full revolution was 2 pi. We were working in radians. So those limits that we found, sine x over x and 1 minus cosine x over x, we found those limits assuming we were working in radians. So all of the formulas that we have found in this section assume we are measuring things in radians. There will be times when you're given a problem in degrees and you need to do some calculus. Great. Convert to radians, do the calculus, convert back to degrees. The formulas that we have for the derivatives all suppose that we are working in radians, and that makes a difference. If you think about it, okay, if I'm driving on the freeway and I'm driving at 60 miles an hour and I'm driving north and I drive all the way into Canada, okay, the Canadians aren't going to think of me as driving at 60 miles an hour. They're going to think in terms of kilometers per hour, and they're going to have a different number for how fast I'm going. It's not that my speed has changed, it's that when you measure it in different units, you get a different numeric answer for that. Okay? So very important whenever we're working with any of these trig functions and doing calculus that we are working in radians. Okay, so let's see. I said it's a 60-degree angle, but in radians, that would be pi over 3. So alpha, my reference angle, is pi over 3. Okay. So here, x I can see is just pi minus alpha. That's going to be pi minus pi over 3, so that's 2 pi over 3. Here, x is pi plus alpha. That's pi plus pi over 3, so that's 4 pi over 3. So my two solutions between 0 and 2 pi are 2 pi over 3 and 4 pi over 3. Again, if you got that answer by just going to the unit circle and picking out the places where the x value was -1/2, that's a perfectly acceptable way of getting there. This is how I usually work through things. You should be familiar with this process of using reference angles, because if the reference angle isn't nice, if the reference angle isn't pi over 6 or pi over 4 or pi over 3, so that that point isn't one of the points that most people have memorized from the unit circle, you can still work through it even if you have to describe your reference angle using inverse trig. Okay, but however you got here, that's where we should be. Now for all x, we just add a multiple of the period. So that would be 2 pi over 3 plus 2 pi n, or 4 pi over 3 plus 2 pi n, where n, I want to make sure I specify, is an integer. And the fastest way of writing that is an element of that fancy z tells me it's an element of the set of integers.